So good morning. You have a problem based on skin depth. Okay, so see, electromagnetic wave traveling in a dielectric medium strikes a large block of brass. Okay, and the conductivity of this brass material is given by 1.6 10 raised to the power of 7 Siemen. Okay, Simon per meter, you can say Simon per meter. Okay, units of conductivity sigma is this. Now brass exhibits intrinsic impedance of eta. So intrinsic impedance eta is a complex quantity. You have both amplitude as well as phase stuff. Now find the skin depth in the brass material. So anyways, this brass is made up of, if I take brass, so brass is an alloy of copper and zinc generally. Okay, so what you have is this. Say you have something like this. Say you have, say, your brass material. Okay, you have some brass material, something like this, with some thickness. Say you have EM wave is, yeah, so EM wave is traveling in this dielectric medium. Okay, so this is my dielectric medium. So this medium 1 is my dielectric medium, and this is what your medium 2. Okay, this is your medium 2, your brass medium. So this is almost a conducting medium. Now he just gave that brass exhibits intrinsic impedance eta as equal to 0.0545 degrees. So therefore find the skin depth, you know very well. So skin depth means, for example, you see, you know that this is a conductor, say conductor wall. If wave is going all the way like this, now within some thickness, okay, you take some thickness, something like this, maybe. So this is what your delta, skin depth delta. That means, so beyond this, the wave suffers almost full attenuation. Okay, so the wave just decays like this, and hereafter it attenuates almost full attenuation. So delta will talk about that. Okay, the depth of penetration beyond which the wave almost decays to zero. So that is what, of course, your skin depth, and already we studied about skin depth in detail. So I just don't want to go for those details now, because you know that already. So fine. So what I must find is, I must find skin depth. So delta I must find. Okay. So eta is given to you. So you have delta, but eta is given to you. And this is your conducting medium. Your brass material is your conducting medium. So I know for a conducting medium, see, generally what is eta? In general, eta is equal to j omega mu by sigma plus j omega epsilon sitting inside a square root. So for a conductor, I know a conductivity dominates. If I take a conducting or high loss medium, so sigma is far greater than omega epsilon. Okay, sigma is far greater than this. And if we plug in this condition, so you know very well now eta is approximately, so j omega mu by sigma. So I can neglect this term now because this guy is dominating when compared to this. So you can neglect this, and equal to will become approximately, sorry, what I'm writing here. So j omega mu by sigma under square. So equal to became now approximately equal to. So knowing this eta, now what we do is this. Let me save it. Let me give it 1. I know my eta is that, so therefore I take my eta is equal to j omega mu over sigma, and this guy is sitting inside a square root. All right. So I know square root of j. Square root of j is like, for example, I have j. And I can write j as e power j pi by 2, because cos pi by 2 plus j sin pi by 2, cos pi by 2 is 0, sin pi by 2 is 1, so therefore you have j. So square root of this stuff. So that is e to the power of j pi by 2, and the square root of that, you can take it as like this. And so therefore it becomes e to the power of j pi by 4. So therefore you have 1 over root 2 plus j 1 over root 2. Euler form expansion. Okay, so therefore you would get omega mu by 2 sigma, because square root of j is this. Okay, square root of j is this. So I get again j omega mu over 2 sigma. So I can say that eta is equal to the intrinsic impedance of brass material is given like this. Okay, so I can take this one as some RS, some skin resistance, and this is J, and this one I take it as some reactance. Okay, XS. So RS. So I can say that anyways RS is equal to XS, because both are same. You have same form. Okay, and of course gamma is equal to alpha plus of course j beta. For in conducting medium or high loss medium, I know that alpha equal to beta, so alpha is equal to omega mu sigma by 2 plus j beta. Also already we proved this one, right? So already we proved this stuff, and now we are going to find intrinsic, I mean our skin depth. So delta, I know that delta multiplied by, I take this RS, okay, skin resistance RS, this is RS is this, delta multiplied by RS equal to 1 over sigma. I know this already. So how do you get this? So I know very well, already this also we have done in class. This is like alpha, this is beta, both are same. So I know delta is equal to 1 over alpha, yeah, in high loss medium. In high loss medium, high loss means conductor medium. So electromagnetic waves hate conductors. They love to travel in free space or vacuum. Okay, anyways, so delta equal to 1 over alpha. If alpha equal to this, so delta becomes 2 over omega mu sigma. Okay, now delta multiplied by RS. So if I take this guy, so that is 2 over omega mu sigma. Okay, I multiply this with RS. What is my RS now? Say RS is this, that is omega mu by 2 sigma. Now what happens? Omega mu done. This is done with this 2 2. So you have 1 over square root of sigma, 1 over a square root of the sigma. So of course you will have 1 over sigma. So delta RS equal to, we know it is 1 over sigma. Okay, so RS you can find from this, right? RS we can find from this. And can I say, okay, let me go to next slide. Let me first copy this. Just want to copy this. Okay, otherwise I'll not go to next slide. Let me stay back here. Let me remove this. Right. So let me use it now. So can I say now like this? RS equal to XS is equal to, I can say 0.05 divided by square root of 2. All right. So I can say this because in the given problem, if you see a problem, you just see a problem, eta is given like this. My other things, eta is given 0.05 at an angle 45 degrees. You have a phase difference between E and H. Okay. The meaning of this 45 degrees is that when EM wave is entering this brass material, now here there is no, see for example, there is no phase difference between E and H components in this electric medium. But the moment that wave enters this brass material, in this case conducting medium, there will be a phase difference between E and H, and that is 45 degrees. Otherwise, we could say E is leading H by 45 degrees in the brass material. So it's given to you already intrinsic impedance of brass material equal to 0.05, 45 degrees. So therefore, I use that. So given to me already. So given given eta is equal to 0.05, 45 degrees. So I can say eta is equal to 0.05 by root 2 plus j, again same 0.05 by root. So I can say rs equal to xs equal to 0.05 by root 2. So you can simply, let's try to find for this rs. Okay, just try to find this. So you would get around 35.35 multiplied by 10 to the power of minus 3 ohms. All right, now just come here. Now delta equal to 1 by sigma rs. Okay, so what is given to you? Sigma is given to you like so. Delta equal to 1 over, so let me see my sigma. Sigma is given to you as 1.6 times 10 to the power of 7. So therefore I take I have sigma as 1.6 10 power 7 multiplied by rs. So rs equal to, we got 35.35 multiplied by 10 to the power of minus 3. Okay, you just find it, you get some answer, whatever, millimeter, micrometer, whatever, just take it. Generally delta is measured in micrometers. Okay, in general in SI units you can take in meters. Okay, generally you fall like this, micrometer, millimeter, like that for delta. Okay, that's it. So that is straightforward. Okay, so that's it for now, and I'll come up with another problem in the next class. Okay, thank you.